This program is brought to you by Stanford on iTunes U at Stanford University. Please visit us at itunes.stanford.edu.
I just want to do one thing, actually, before we start the material of the class. A whole bunch of people, a lot of people, particularly people from Europe, who actually follow these things on the internet, seem very puzzled. They send me email. Even some of my friends in Europe who are physicists who are following it are very curious about what's going on here. They don't see you people. They only see me. And they know that I'm teaching a class in this or that special topic in classical mechanics or whatever. And they can sense that there's something a little bit different about it. They can sense that it's not a standard undergraduate or graduate course in these subjects. And they ask me, what is this? What is this about? Or who are these people you're teaching to? They can tell it. And most of them don't know what continuing education means. They didn't know what it meant. And so they ask me. I thought I would tell them over the internet what this class is. It's continuing education, which means education for people not from Stanford, people not, they can be from Stanford. Some of the people probably are either employed by Stanford, maybe were students at Stanford, but almost everybody in this class is a little bit too old to be an undergraduate student, even a little bit too old to be a graduate student. They're people from the community, from Palo Alto, from Mountain View, from, who lives further than Mountain View? Okay, what's the furthest you come for this? Where? Foster City. Okay, so that's 20 miles away. So people from within a certain radius, I don't know, whatever the radius is, are allowed to come and take courses at Stanford. They pay a bit of money for it, and a professor teaches them. Now, this is not, it is most definitely not your standard freshman physics. There's another guy on the internet who teaches freshman physics, and totally does it very well. That's not what this is. This is the real McCoy, theoretical physics at the full-scale level. We use equations. We not only use equations, we sometimes use hard equations, but we tend to try to use the simplest equations that will do the job. Basically, we try to keep it minimal. Just out of curiosity, I more or less know the answer just by looking, but what the age distribution of people here is by comparison. Is there anybody here under 40? Yeah, there's maybe one handful of people under 40. Incidentally, for those who can't see the audience, there's probably about 100 people in the room. I'm not sure. It's a small theater with a lot of seats. It's a lecture theater, more or less filled up. And maybe 4 or 5 or 3 or 4 people were under 40. Let's see. Let's go to the other end. How many people here are over 70? A good deal more, maybe 10 or 12. Anybody over 80? We got a couple of people over 80. Anybody over 90 this time? Oh, there have been people over 90. There have been people over 90 in this class. So you see the age distribution is such that basically people want to get to the basic ideas fast. They don't have a hell of a lot of time. They want to get there fast. So I try to tell them in some minimal way what the basic things you really have to know in order to get on to the next thing. Sometimes the basic things that you need to know are a little more difficult, a little more elaborate. We do them anyway. We do them as efficiently and as straightforwardly and with the minimal amount of stuff to get them right, to get them really right. Not metaphor, not analogy, but equations when necessary. What else can I say about this class? I guess it has various names. Quantum mechanics, the Physics 25. I'm inclined to call it quantum mechanics for old people, including myself. Anyway, the first course in the series, let me just say what the outline of the whole course of courses is. These series of courses will consist of about 6 10-lecture series. The first of which was in classical mechanics. The classical mechanics is the basis of all classical physics. Classical means before quantum mechanics. Anything that doesn't involve quantum mechanics, or which ignores quantum mechanics, or which is in a range of parameters where quantum mechanics can be replaced by basic classical logic, that's called classical physics. So the first class was classical mechanics, which is in some sense the basis for all of physics, the motion of objects, the energy of objects, the momentum of objects, what the characteristic behavior of systems is as they evolve with time, and so forth. We discussed that last quarter, and anybody who is thinking of following these classes should begin with that. The next class, which is already on the internet, was called, I believe, Quantum Entanglement. Now, this is also a class on quantum mechanics, and it will be self-contained, but I would strongly advise anybody who's following to go to course number 2. Was it called Quantum Entanglement? Does anybody remember? I think it was called Quantum Entanglement. It is also on the internet. It was the first one that was on the internet. And to get that under your belt first, before attempting to do the full-scale quantum mechanics that we're going to do here, although what I'm going to do is pretty self-contained. I'm going to start this evening with some basic thoughts about the deep differences in the logic of classical mechanics and quantum mechanics. Or classical, maybe even mechanics is too strong a word. Classical physics and quantum physics. There are some very queer phenomena in quantum physics that don't exist in classical physics. Now, one of them is the fact that quantum mechanics is based on statistical thinking, randomness, a certain degree of, not imprecision, that's not the right word, a certain degree of non-deterministic or indeterministic behavior, unpredictability, that's the word I'm looking for, unpredictability, but it's a special kind of unpredictability. Einstein famously said, God does not play dice. Niels Bohr told him, Einstein, don't tell God what to do. But in fact, in a sense, God, I don't know if there's a God. When I use the word God in the same sense that physicists always use it, meaning the laws of physics or something like that. The laws of physics don't play dice, at least not in the standard sense. Let me imagine for you a theory that's based on a bit of statistics, which is not the way quantum mechanics works. And then I'll illustrate it for you by showing you some of the differences. Imagine that there was an element of randomness